So let us work out these conversions. First one is bute 1 into iodobutane. So let us write bute 1 in. Bute 1 in, that is CH3, CH2, CH double bond CH2. So this is bute 1 in, right? So what we have to convert? We have to convert this into iodobutane. So what is iodobutane? Let me write here. CH3, CH2, CH2, CH2I. This is iodobutane. So this is what we have to do. What happened here? This double bond has been converted and iodine has been added here, right? This is what happened here. What we have to do, how we can make this conversion? First of all, what we have to do, we have to convert into corresponding bromide. That is, this can be treated with HBr in the presence of light and the presence of peroxide. Peroxide in the sense anti-Marconico rule. Anti-Marconico rule in the sense, what is Marconico rule? That is negative part of addendum will go to the carbon with less number of hydrogen atoms. So this is Marconico rule. So this is Marconico. This is Marconico rule. So anti-Marconico rule means exactly opposite to that. So as per Marconico rule, what we have to do? The HBr in the sense it will be H plus and Br minus. H plus and Br minus. So as per Marconico rule, so this negative part should go to the carbon atom which is having the less number of hydrogen atoms. But peroxide is here. Peroxide means it works in the against way. That is anti-Marconico's rule. Anti-Marconico rule. So what happens that now this bromine will go to the carbon which is having higher number of carbon atoms and this hydrogen will move to this carbon. Thus gives result to CH3, CH2, CH2, CH2Br, right? So this is butyl bromide. This is butyl bromide. Now what we have to obtain? We have to obtain iodobutane, right? This is bromobutane. So this bromine should be exchanged into iodine. So for that we can go for a halogen exchange reaction. What is halogen exchange reaction? Let us go halogen exchange. Halogen exchange reaction. Halogen exchange reaction. So what are the two types of halogen exchange reaction? One is Finkelstein reaction. One is Finkelstein reaction. Another one is Schwarz reaction. Schwarz reaction, right? Finkelstein reaction in the sense it is an iodine exchange reaction. So iodine exchange in the sense what is that? That is sodium iodide will be used in dry acetone. Dry acetone, right? Here this iodine will be exchanged for any halide. So that is why it is called a halogen exchange reaction. In Schwarz reaction, metallic fluoride is used. Metallic fluoride. So it is a fluorine exchange reaction. Now what we have to do? We have to get iodine here. So let us go for Finkelstein reaction. Let us use sodium iodide dry acetone. Sodium iodide dry acetone. So what it will do? It will replace the bromine here. Sodium bromide will be moved out. So we can get CH3, CH2, CH2, CH2I. This is the desired product. That is iodobutane or butyl iodide or 1-iodobutane. So this is how the conversion takes place. that is bute 1 into 1 iodobutane. So let us narrate the process again. So first bute 1 is taken, that bute 1 is treated with HBr in the presence of peroxide. As per anti-Marconico rule, we can get bromobutane. This bromobutane subjected to Finkelstein reaction, the presence of sodium iodine triacetone, which gives 1 iodobutane. So that is why the first thing is achieved. Got it? Next, let us go for benzene to acetophenone. Benzene to acetophenone. Let us write the formula there. So benzene. So what we have to do? We have to make it as acetophenone. Aceto. This is aceto. That is CH3 C double bond O. So this is called as acetyl group. And phenone. Phenone in the sense here a phenyl group will be attached. Got it? This is acetophenone. So what we have to go? We have to convert the benzene into acetophenone, right? So what is the difference here between the benzene and the acetophenone? The difference is this one. What is this? This group is called acetyl group, right? Acetyl group. Acetyl group. So what we have to do? So we have to insert this acetyl group in this benzene ring. So that process is called acetylation. Acetylation. That is insertion of the acetyl group in the benzene ring. Okay. Now let us go for it. Let us take the benzene ring plus we have to insert this group. So we are going to add acetyl chloride, that is CH3COCl, right? In the presence of AlCl3, the presence of a Lewis acid, that is in the presence of anhydrous AlCl3, right? So what is the role of AlCl3? It is a Lewis acid. Lewis acid. What this Lewis acid will do? The Lewis acid will abstract this one, that is a Cl, and become AlCl4 minus, and then a hydrogen will be released from the benzene, and that hydrogen will grab the Cl from the AlCl3 and HCl will be formed, and the remaining part CH3C double bond O will be attached to the benzene ring. So that will give rise to C double bond O CH3 plus HCl, right? So this is, so what happened here? This is benzene, this is acetophenone. So what we had made? We had made acetylation. So this process is called acetylation. Let's go for the next thing. Next question. Ethanol to propane nitrile. Ethanol to propane nitrile. So ethanol is familiar to you. Propane nitrile, let me write the formula. Let me write ethanol, that is CH3 CH2OH. So this should be converted into propane nitrile. Nitrile in the sense there should be CN. Cyanide is otherwise called as nitrile. So propane in the sense there should be 3 carbon atoms. 1 carbon atom is already here. So we can write CH3 CH2. CH3 CH2. CH3 CH2. So this is propane nitrile, right? This is called a propane nitrate. So this alcohol should be converted into this cyanide. The alcohol should be converted into this cyanide. So first of all, what we have to do? We have to convert this alcohol into an alkyl halide. Let us convert this alcohol into alkyl halide. So for that, what we have to do? We have to treat with red phosphorus bromine. Red phosphorus bromine, right? So what happens that this gets converted into CH3 CH2Br, right? This gets converted into corresponding alkyl halide, right? So when this alkyl halide is treated with KCN, potassium cyanide, in the presence of aqueous KOH. Aqueous KOH, substitution reaction will take place. So what happened that this CN will substitute the Br and KBr will move away. So this gives rise to CH3 CH2 CN. So this is called a propane nitrile. So this ethanol in the presence of red phosphorus and bromine is converted into ethyl bromide, which in turn treated with KCN in the presence of aqueous KOH to give propane nitrile.